Now the next topic is deriving the characteristic equation of a flip-flop, which defines the next state of the flip-flop in terms of the present state and the present excitation. And in order to design the characteristic equation, we need to design a truth table, and which basically designed from the basic truth table of a JK flip-flop. And what is the difference between these two tables? There is a basic difference. There is no any difference, but here we have just replace, or we have just relocate this column into the front. Here you can see that there is a front, and what we have done, we have just put it into a sequence. So here you can randomly check any value. For example, this one is a when Qn is a 1 and Jnk is a 0 1, your output must be 1. So in this case 1 0, so Jnk is a 1 0 and Qn is a 1, Qn is a 1, Qn is a 1, and your output will be 1. So here is a 1. So basically what we have done nothing but just relocate the Qn, which is a past output, into the first column. That's we have done. And now we have again numbering this outputs. These are your output, and the numbering in order to design the K-map and put the values and reduce the equation with the help of a K-map and make the some two pairs are there, and then you can design this equation. Just you have to remember that this one is a Q, J and K. This one is a B and C. This one is a B and C, and here you are designing for Qn plus 1. This one is a D. So basically you have to design the characteristic equation of a JK flip-flop with the help of this method. And there is another characteristic equation for a SR flip-flop, which has been designed with the help of a truth table of a SR flip-flop. Again we have just relocate this column into the front in this case, and just change the entire values like that, and reshuffle these values. And here we randomly check any value. For example, this one, when S10, S is 1, R is 0, S is 1, R is 0, and Qn is a 1. So basically it is defining this row, and your output will be 1. So here we have written the 1. So once we have written the output or reshuffle the outputs, we can write it as a 0 1 for ease in designing the K-maps. And here we have got the X basically defines the invalid states, and these are the invalid states which and these are referred to as a basically don't care conditions, and which are used to design the characteristic equation of a SR flip-flop. And this is a quad pair, and quad, and this one is a pair of a Qn R bar, and this one is a characteristic equation of a SR flip-flop.